Zainab, am I audible?
Yes, ma'am.
All right. So we were discussing the temperature dependence on resistance and resistivity in the last class. These were the two formula that we concluded and how they were dependent on number density, how they were dependent on the tau, that was average relaxation time. So the graph that was plotted with conductors, this was the graph. Initially it was non-linear, then the graph became linear. For alloys also it was increasing linearly, but the variation was very small. And then we have semiconductors where the graph is a hyperbolic graph because it is inversely proportional. You increase the temperature, resistance and resistivity decrease, and vice versa. When you decrease the temperature, then only resistance will increase. And this was a graph related to superconductors. And we stopped at this formula, RT is equal to R naught 1 plus alpha T minus T naught. Now, we didn't practice any question regarding that. Let's just practice a question and then I'll start with the fresh topic. Assignment discussion is also left. See, this says an electric toaster uses nichrome for its heating element. So you have, it's basically talking about electric toaster is there, nichrome is present inside it and it is performing the heating work. But you don't have the question related to power or heating. It is saying when a negligibly small current passes through it, its resistance at room temperature. The resistance at the room temperature are not. Resistance at room temperature is 75.3. And what's the room temperature? It has given in the bracket 27 degrees Celsius. The temperature at the room temperature is basically 27 degrees. It says when the toaster is connected to a 230 volt supply, you have a resistance whose value is 70. No, resistance is not given. Okay, resistance is not given to us. Rather than the resistance, they have given us the voltage. So it is saying voltage is 230. So you have the voltage 230 volt. The current settles to 2.68 amperes. Here the value of current is 2.68 amperes. And apart from this, it says alpha, which is the coefficient temperature, coefficient of resistance, is 1.7 into 10 to the power minus 4 per degree Celsius. This is the data that we can extract from the questions. Whenever you have the numericals, any exam you are appearing for, try to write down whatever data you have from the question. So these are all the data that we can extract from this question. Now, resistance at room temperature, the room temperature we got. It is asking us to calculate the value, steady value of temperature. What is steady value of temperature of nichrome element? Means the T. What is the value of T? But see, from our equation, one more thing is missing. The resistance at this temperature. See, what is the formula? Formula is RT is equal to R naught 1 plus alpha T minus T naught. This was our formula. RT is given here. See, RT is not there. R naught is given. 1, we already know what is 1. T is missing in the question. T naught is already given. So, the mystery behind is that you have the voltage and the current. So you divide them. You divide voltage by current, you will get the resistance and this will come out to be 85.5. You will have RT also with you because they have given you voltage and current to calculate this resistance. Now you are free to just put the values. All the things are there. Only one variable T is missing. RT is 85.5 is equal to R naught, which is 75.3. 1 plus alpha is 1.7 into 10 to the power minus 4. T minus T naught. T we don't know, minus T naught is 27 degrees Celsius. This is one equation, one variable. You have to calculate the value of T. You first divide them, then you subtract 1 from it, and you will multiply these two, then add the value of T when you shift. So this way you will get the value. It will be a big value. around 847 degrees Celsius, you will get your answer. Just confirm also, this is what I remember, but just cross check if any digit is wrong or what. This is how you just have the question based on resistance. I'll discuss the assignment also. First write it, and then I'll start with a fresh topic, internal resistance and the potential difference and EMF. EMF of the cell is also left. So please write it first.
Ma'am, can you scroll up?
Done?
Yes.
We are coming to the topic internal resistance. We have three topics that we'll be doing: internal resistance, terminal potential difference, and the electromotive force, EMF. See, let's understand internal resistance first. When you have a cell, this is how the cell is drawn. This is how we write the structure of a cell. So, or the battery that you use. So inside, when you cut open the battery, this is how it looks. And you have a chapter in chemistry, electrochemistry. In there, you will study all these things in detail. So basically, here you have rectangular cathodes. One is known as cathode, one is known as anode. And these electrodes, they are dipped into an electrolytic solution. All these are dipped into an electrolytic solution. What is what are these? These are the electrodes. And what is this? This is the electrolytic solution. So see, when these electrodes are present within this electrolytic solution, what happens? Whatever is the resistance offered by these electrodes as well as this electrolytic solution, it is known as the internal resistance. Means it's the resistance offered by this and this. When you draw a cell to show that it's the resistance of this cell, it's the resistance within the cell, you'll often find the symbol of resistance. The cell is there and the resistor is connected like this, represented by a small r. This is how it is put. I'll write it here also. See here. This is how a cell is connected and the resistor is just connected. Let's say this is some having some EMF E and this has the internal resistance R. Like this, they are connected together. So this means if you see a cell which has a resistor connected just adjacent to it, it doesn't mean this is your resistance of the circuit. This means this is the internal resistance. This is the internal resistance. The rest of the things are same. It means that the SI unit will also be ohm. And see, when we are talking about the internal resistance, this is present beside the cell. But when you are including the external resistance that you calculate, no series and parallel combination and all, that time you will not include this one there. When we'll have all the formula together, I'll tell you how to include the internal resistance in your calculation. So SI unit is your ohm only and it is represented usually by the symbol small r. That's what your internal resistance is. So what is internal resistance? Resistance offered by the electrode and the electrolytic solution of the cell. This is the internal resistance. Battery is offering the resistance. You are not putting a resistor and connected. With the resistor that you are putting and connecting it with your circuit is your external resistor. The resistance already present because of the structure of this electrolytic cell. This is nothing but electrolytic cell. So due to this, it is called as the internal resistance. Write it, then we'll discuss what is EMF. All these terms are very small. Let us discuss them and then we'll combine all the theory part. Please write it from here. Write the heading as internal resistance only. Okay, let's come to electromotive force now. What is this EMF? See, when we are talking about EMF of the cell, EMF, terminal potential difference, internal resistance, all these are very connected terms. Resistance is, of course, related to resistance. Resistance is a different quantity. But when we talk about EMF, or we are talking about the terminal potential difference, there's a minute difference between both of them. And one thing, don't think this is a force. The full form of EMF is electromotive force. Is just a misnomer. It's not a force. It's voltage. Potential, what we study, it's the same thing. This electromotive force is nothing. This is just voltage. So you can use it directly in place of voltage. So now what exactly is this? This internal resistance we talked about in so detail, the potential difference or the potential difference across this internal resistor, it is what is called as the electromotive force. Means when you have the, I'll just draw this circuit. See, this is the cell, this is the internal resistor. So here an E will be put to show that this is the EMF of the cell. EMF of the cell is nothing, it's just the voltage of the cell. Voltage of the cell across the internal resistor. The internal resistor. But see, this is valid even when you have an open circuit. For an open circuit, when the circuit is off, open circuit means see, there's a breakage in your circuit like this. This is what is meant by open circuit. So even if the switch is off, this means the switch is off. Even when the switch is off, you can calculate the EMF for it because internal resistor is there. EMF is nothing, it's just the maximum potential difference across the internal resistor. This is how you can remember it. So what is terminal potential difference then? Terminal potential difference is the potential difference across the external resistor. See, what is the difference between internal resistor and external resistor? Internal resistance is the resistance which has naturally been provided by the cell itself. Okay. And the external resistors are the resistors that we deliberately connect in the circuit to modify the resistance, to modify current. See, if I decrease the value of resistance, you know, V is equal to IR. So resistance and current are inversely proportional. If I want to decrease the resistance, if I decrease the resistance, my current will automatically increase. And if I increase the resistance, current will automatically decrease. So in order to solve all these, we have the external resistors and according to our wish, we can put them. Charges will not flow, yes. In open circuit, charges will not flow through that wire. If a branching has been done, let's say this is a resistor and this is open like this. This is put open like this. And there are other resistors also. So here in this branch, there won't be flow of any current. EMF is possible because across one of the wire, it is zero. Through the entire circuit, the current is not zero. Like this is a breakage in the circuit. Only across this wire, across this resistor, there will be no flow of current. Other resistors, other devices will be still connected in your circuit. That's why we are having the EMF. Okay. Is that clear?
Yes, ma'am.
All right. See, when we draw the circuit, let's say there are various circuits. Now, I'm not focusing on how you are connecting the external resistors. They can be connected in series, they can be connected in parallel, they can be connected, a single resistor can also be connected, they can be connected in any combination. So you reduce all of it and get one R equivalent value. Now, how to get that value, we'll study later. But this you already know in capacitors also we saw that different capacitors are present and we used to write the equivalent capacitance. So here also you will calculate their equivalent resistance. So that's why I'm just writing a single resistor. When I draw single resistor, it does not mean that always you will get a single resistor only. Many resistors could have been there, but we have calculated their equivalent resistance and put it like this. And then we have the cell where we have the internal resistance. So see class, here is the EMF of the cell within the cell for the internal resistance. Here you get the EMF for the internal resistance. And across the ends of the external resistor means throughout this part here, throughout this, you get the terminal potential difference. This is the terminal potential difference. Okay, this is the terminal potential difference. Means across the external resistor, you are going to put the terminal potential difference. So these, we'll see how to calculate them. Right now, you will get R's value directly, but because in the next segment only we have the series and parallel combination. Okay. Now see, when we talk about the formula part for it, the basic formula that we have for it is terminal potential difference is EMF minus current into internal resistance. This is the formula for the terminal potential difference. What is V? This is the terminal potential difference. But what if I don't want terminal potential difference? I just want the current and this is my circuit. See, here I'll get some R equivalent also. Let's say there are, or let's take only one, let's consider one only. Now see, when I am calculating the current, the value of current here, if I'm calculating the current is potential divided by resistance, potential divided by resistance, I is equal to V by R. If here the EMF is E and you don't have any terminal potential difference, like in this case, when we are calculating the EMF, you are not getting an external resistor in your circuit, only internal resistance is there. So you just put voltage as E, but when you are calculating the resistance, you put it as small r. Or if both the resistors are there, then E divided by capital R plus small r in terms of EMF. What if terminal potential difference you need to calculate? See, it will be terminal potential difference can directly be calculated I into R. Current is E by R plus small r into external resistance, that is R. Mainly, this is the main formula, you remember, and this one. This is very important. Of it, even you can forget this one. This will just confuse you. Remember, these two are the main actual formula. Capital R stands for the external resistance. This capital R is standing for the external resistance, and small r is standing for the internal resistance. External resistance, internal resistance. Now, you just want to calculate the potential difference across only one of them, like not within the circuit. I just wrote these equations for this circuit. For this particular circuit, I wrote the equations. What if we just want to calculate just for the external resistance? If I want to calculate the potential just for the external resistor, so take the current, multiply the resistance. If I want to calculate for this one, take the current and multiply this resistance. You will get that current. Okay, like if I want to calculate potential difference across external resistor, so it will be current into the external resistance. If I want to calculate potential difference across internal resistor, I'll just multiply current with the resistance. Now see, terminal potential difference is what? This one, first one, I into R. This one is the terminal potential difference. Potential difference across external resistor. So your formula is V is E minus I R. Tell me class, is it clear till here to all of you? All the formula, anything you want me to repeat or go slow from here? EMF or even this internal resistance part, anything? Is it clear to everyone? Jobita, Jesleen, Zainab?
Yes, ma'am.
Okay, it's clear then. Internal you have written. Okay, start writing from EMF.
Can you tell us?
Done?
No, ma'am.
Done. Class, here you have to identify what is your external register, what is your internal register, and your question will be solved because you just have to identify here first. Once the symbols are identified, the formula is very simple and questions here are also very simple. See, the resistor that is connected adjacent to the cell, this will be your internal resistance and this will be your external resistance. So in the first part, when it says to calculate the current, this is the EMF given, EMF of the cell. So the current is basically the EMF divided by the external resistor plus internal resistor. EMF is given as 22, external resistor is 10, internal resistor is 1. That becomes 22 by 11, that is 2 amperes. Second says potential difference across external resistor, that is your terminal potential difference. So across external resistor, we have to find out. So potential difference across the external one will be current into the external resistance. See, current is 2 into external resistance is 10. That is 20. This is your terminal potential difference. We'll calculate it in the fourth part. It will come the same. Potential difference across internal resistors. So when you have to calculate the potential difference across internal resistor, take the current, multiply it with the internal resistor. See, current is 2. This is 1. That is 2 volt. Right? This is 1. This is 2. So 1 into 2 is 2 volt. Now it says terminal potential difference. Even if we go by this formula, V is equal to E minus IR. EMF is 22 minus I is 2, small r is 1. 22 minus 2, that is 20 volt. Because this is the definition of terminal potential difference, so the answer had to be the same. There are certain graphical questions that have come recently also in the exams. I want to discuss that. But first, tell me, till here, is it clear?
Yes.
Okay. Write down this. completed? See, we have the formula V is equal to E minus IR, which is the usual case. It is in case of discharging of a cell. Means when the current comes out of the negative terminal of the cell and enters, this means the whole circuit is there. From here, the current is going and it will current is coming out from the positive terminal of the cell. From here, this side it will move. It will complete the entire circuit and it will come again to the negative terminal. Like this is the motion of the current in this. So that is known as discharging of cell. Cell is giving the current out from the positive terminal. If you reverse it, means current is coming from the negative terminal and it is exiting through the positive negative and entering through the positive, just opposite. Just put a positive sign, that is the showing the discharge, the charging of a cell. In discharging of cell, the current comes out from the positive terminal, enters the negative terminal. In charging of cell, the current comes from the negative and enters the positive. But here the formula V is E minus IR. Here same thing, but you have E plus IR. So this is the difference. And this is very important. Key is open, I is 0 and V is 0. See, when you have the value of current as 0, so in this equation, V is equal to E minus IR. Yes, I'll explain it. See, let's say we have a circuit like this. Resistor is there, battery is there, internal resistance like this. The whole circuit is put. Big whole circuit is there. Now, when the current is moving in this direction, like this, means from the positive and entering into the negative like this. Then for the terminal potential difference, here we use the formula E minus IR. But if you reverse it, if I take this same here, if I take it, let's say this is the resistor, this is the cell, this is the internal resistor like this. If this is the direction of current is supplied by the battery, then you use E plus IR to calculate the potential difference here. Now is it clear?
Yes, sir.
Okay. See, when your current becomes 0, so in this equation, V is I minus IR, E minus IR, this term will be 0. Potential will be directly equal to EMF. But you have various graphical questions based on this that we'll just see the next. Write down these note points, then I'll start with this question. Please write down that as note points. No. In charging, the current is moving from the negative. It is moving from the negative, and the whole circuit is completed and it is coming back to the positive. In discharging, it is moving from the positive and coming back to negative. See here, you have the graph between the voltage and current. So it says the plot of the variation of potential difference across a combination of three identical cells in series. So if three identical cells are connected in series, so it's something like this. They have their own EMFs and own internal resistances. So we'll discuss this also now only, that when you calculate the equivalent resistance, here in this case, the equivalent resistance will be equivalent, not resistance, equivalent EMF of the cell will be, just add all of it because they are identical, you add all of it. You get 3E here. You add all the equivalent resistance. I'll discuss this in detail. How do we calculate this and how, what all things can be there, how the questions can change. This we'll discuss. Then internal resistance will be 3R. Now it is saying, what do you have to calculate here? The plot is given across combination of three identical cells in series versus current. What is the EMF and internal resistance of the cell? E and R you have to find out. The graph is between the potential difference, V versus I graph is there. If I take a point here, just this point, or if I just take this point, what are these? These are just coordinates on the axis. These are not within the plane. If I look at this one, if I mark this point, this one, this is whatever is the value. This will be some y comma 0, not y comma 0, 0 comma y. Similarly, if I choose this point, this will be x comma 0. That's how we write the coordinates on the x and y axis. This part will be having only the x-axis part. The rest of it will be 0 because y is not present here. Do you agree? These are the coordinates 0 comma y and x comma 0 for these 2 points which I have marked. Is it?
Can you repeat the question?
See, I have marked 2 points. Just see, am I right? This point on the y-axis. This point on the y-axis. If I take its coordinate, will it be 0 comma y? Means x part will be 0 and y part will have this y.
Yes, ma'am.
Yes? And see, if I take the x coordinate here, so only x's value will be there, y-axis term will be 0. Right? Christine Jobita, what about you? Are you understanding this part? Okay. See, so let me consider this point. So let's say here the potential is 6 volt. So current for this will be 6 volt. At 6 volt, current is 0 because there is no current. This is just the coordinate on the y-axis. This is 0 comma y. 0 for current, y is 6. This point is nothing but 0 comma 6. Let me change this y into 0 comma 6 now. Now you'll understand. This will be 6 volt and current will be 0. So if I put the value V is equal to E minus IR, voltage is 6, EMF is 3 times E minus IR. This whole term is 0. So look, EMF is equal to 6 by 3, that is equal to 2 volt. So we have got the value of the EMF as 2 volt. This is done, EMF. Let's come to internal resistance. That let's take this value. Now, instead of making it as x, I am putting its actual value. It's given on the graph as 1. This means this is 1 comma 0. Means at this point, when we have current equal to 1 ampere, potential is 0. Reverse 1 comma 0. When you mark a point on the axis, the other coordinate is 0. That's why we are marking z is also 0, but we don't need the z axis. Now let me put it in the equation. 0 is equal to 3 into E minus current is 1 and what's the resistance? 3R. Right? This is how we write the internal resistance. Do you agree here? See, in the equation, let me write the main equation. In the main equation of V is equal to E minus IR. What is voltage? It's 0. So I'm writing terminal potential difference as 0. What is EMF? It is 3 times E. Right? This is 3 times E. So this is 3 into E minus what is current? 1 ampere. What is internal resistance? 3 into R. Now from here, if I shift this, 3R is equal to 3 into E and E is 2. 3 gets cancelled, R is equal to 2 ohms. So we have got the values of resistance and EMF using the graph. Tell me, is this graphical question is clear to all of you?
Yes,
Should I
ma'am.
repeat? Clear? Okay. One thing I'll tell you, see, when you have these graphs present, how can you interpret this graph? If I write V is equal to E minus IR, let me reverse it. V is equal to minus R into I plus E. It's the same thing. E minus IR. This can be written as minus R into I plus E, same thing. Now, if I compare it with the equation of a straight line, because we know V versus I will always be a straight line graph. Whether it's like this or it's like this, it will always be because it obeys Ohm's law. So here, when I write the equation for a linear equation, basically when I write the linear equation, y is equal to mx plus c. What is this? This is the linear equation. Now see, what are all these values? Let's check. Y is, what does y mean? What y means? Whatever is represented on the y-axis. So we have voltage on the y-axis. So that is right. This is correct. M is basically representing the slope of the graph. So slope of the V versus I graph, in this case, terminal potential difference, slope of the graph will be R. No need to put minus because resistance can never be negative. So you have to take its modulus. You can directly say which is internal resistance. If somebody asks you, what is the value of us, or how can we calculate the internal resistance? We can calculate it using the slope of the graph. And how do we calculate the slope? Using tan theta. That's how we calculate the slope of the graph. Next, M is the slope. X is basically what is represented on the x-axis, that is current. Yes, current. X-axis has current. See, y-axis had this. So y was overlapping with V. Current was there on the x-axis. V versus I graph we are plotting. This is V versus I graph. Okay. And C is basically known as the y-intercept. So the y-intercept of the graph will give you the EMF, that is electromotive force. See how? This is the graph. Let's say this, let's consider this graph only. See, this is V versus I graph, right? V versus I graph, y-axis, x-axis. The slope of this graph, that is the tan theta, will give you the value of internal resistance. This is known as y-intercept, where you are cutting the y-axis. See, I have cut the y, not I have, means the graph is cutting it here. So this whole region, 6 volt, this whole part becomes the y-intercept. So in this case, it will be equal to EMF. That's it. This is what is needed. Why did I explain you so in this in so detail? Was because once the question has been asked, what's the slope of the graph? What's the y-intercept? In your previous year board exams, this has been asked. This part. So to understand this, why the slope is equal to R and why y-intercept is EMF, you need to know the basic linear equation, where M is representing the slope of the graph, C is representing the y-intercept. Is this clear to all of you?
Yes, ma'am.
Okay, Jasleen, what about you? Okay, all right. Write it then. Write down this question. This completes with this whole topic. Now we will straight away start with series and parallel connection of cell. Before that, I'll just discuss this part. Means this topic, equal connection of cells in series. and parallel. This I'll discuss.